Inside the Classroom takes an in-depth look at one of Team Hardin County Schools' best teachers in action, featuring comments, class instruction, and insight inside the classroom.
I became a teacher like many people become teachers because they love kids, because they want to help our students, and you don't realize what an impact you have on the kids until you're actually in a classroom and you are affecting their lives and you're helping them, you're mentoring them, some of the students you're their friend, and some of them you are the only positive role model that they have. So just to help my students is one reason why I stay a teacher.
All right, so we have been looking at probability. We've been looking at experimental and theoretical probability. We looked at our vocabulary words the last few days, okay? You should have 4 vocabulary words for this unit, along with the back sheet of your vocab sheet that has your probability number line. We have a quiz on Friday. Make sure that you're studying your vocabulary words.
There are 2 teachers that I had growing up that wonderful teachers, Miss Dennis and Mr. Mike Allen. Miss Dennis, she was the person that loved every student. She absolutely loved every student, and I try to do that in my classroom, love every student no matter how their behavior is that day. And Mike Allen was my reading teacher here at West Hardin Middle School, and he was the person that made me enjoy reading. I hated to read before I had his class. I was embarrassed to read out loud, and he just made it feel that everyone makes mistakes, and I just try to take that back into my classroom.
So the way Quiz Trade works, Max, everyone's going to get a card, okay? On your card, there is a term and a definition, okay? Or it could be a question. Like, what is the probability of landing on a 9, okay? Or this one, theoretical probability. And then you're going to have to say what the theoretical probability is, okay? It's called Quiz Trade for a reason, because what you're going to do is you're going to stand up, you're going to raise your hand high, and then you're going to pair up with someone, okay? Someone that has their hand raised. You're going to quiz them on your card. What is the probability? You may have to show them the card, or you may have to say, what is the theoretical probability, okay? And then you're going to have to say, okay, yes, you're right, or you may have to coach them. If they say, I don't know, then you're going to have to coach them. You're going to have to say, well, wait, a dice has 6 outcomes, so the probability is not going to be out of 4, it's going to be out of 6, okay? So you're coaching them, and you have the answers on the other side, so you can probably help them. And then your partner is going to quiz you, okay? After you do that, you're going to trade cards and you're going to praise. You're going to say, thank you for being my partner, or great job, okay? Then you finish, your hand goes back up. Oh, I see Amelia. She has her hand raised. I'm going to be with Amelia now, okay? The point is that if she has her hand raised, I have my hand raised, you're going to be partners with her. Do not bypass someone because you don't want to be partners with them. Okay, I've said that 100 times. Be with the person that is closest to you.
Ms. Brangers is an effective teacher because I believe she creates one-on-one relationships with students. She is very hands-on. Anytime you go in the classroom to observe, the children are always involved, whether it be cooperative learning with each other or working with math manipulatives. They're always hands-on and doing active things in the classroom.
And you may see some of the cards twice. The reason for that is because the ones that I have given twice are the ones that are more important. Okay, so you may see theoretical probability twice when doing this, and it may not be the exact same card, but it is because I want you to know that one. Yeah.
Miss Brangers, she makes all the learning that should be hard, she makes it easier by like putting it in games and explaining it for us. And like she'll have like songs from YouTube for like a subject or something.
All right, stand up. Hands up, pair up, go.
What she does is like she makes learning fun by like
what we do is we play games for learning. Like we'll do multiplication war and we'll play division war, and then she'll just do a bunch of like a lot of times she'll find things on Pinterest and we'll do stuff like that.
All right, so on your table, we have 3 different experiments, okay? You have 3 different experiments. You have 2 sheets for you and your partner. You both are not going to write on each, okay? So you have 1 pack for both of you. You have 3 experiments. Let's look through these just kind of to look at, okay, to kind of give you an idea on what we're doing. We have looked at theoretical probability. We've looked at experimental probability. All right, we have looked at theoretical probability and experimental probability. We've looked at both of those, but we haven't compared the two. Okay, we haven't compared the two. You should know that experimental probability is what happens in the experiment. You should also know that theoretical probability is what should happen. Okay, I should get this. But we all know that it doesn't always work out like that, because when we do our experiment, it changes. It's not really what it should be. Okay, so we're going to have 3 experiments. You are not going to have to do all 3. You're going to get to pick which ones, and I'm going to talk about that in a second.
Because she makes math and algebra fun, because I used to not like math as much as I do now, and she made it really, really fun.
Second. But let's look at experiment number 1 first. Okay, you are going to have 1 number cube for each pair, 1 number cube, and don't worry about it saying counter and tallier. I'll explain that in just a second too. Okay, so you're going to have to find the theoretical probability of rolling a 5. So what is the theoretical probability of rolling a 5 on 1 number cube? At this point, you should know the answer to that. And then you're going to have to write it as a fraction and a percent. I was nice today. Normally, I'm not as nice, but I have given you a couple of calculators at your desk, so you can just divide using your calculator. You don't have to do it off on the side. Then, you're going to do the experiment. The first one for experiment number 1, you're going to roll the die 25 times. One person is going to sit there and roll 25 times, counting maybe in their head, 1, 2, 3. The other person, so one is the counter, the other person is the tallier. They're going to tally right here, because you can write on this. You're going to tally how many times you got a 5. So one person is the roller and the counter. I went 1, 2, 3, 4. Oh, I got a 5. Tell your partner. 4, 5, 6. And you keep going 25 times. That part makes sense. Okay. All right, then you're going to fill out the rest of this. On the dice activity, you're going to roll it another 25 times. And then the last question, it has you comparing the theoretical probability to the experimental probability.
Today's lesson, they are going to be doing what's called quiz trade. It's actually a Kagan structure. At West Hardin, we've been trying to hit vocabulary really hard, and so it's a vocabulary structure where the kids are reviewing the vocabulary words. They are going to have 3 experiments on theoretical and experimental probability after that. We've looked at both of those, but now today they're going to be comparing the 2. And then after that, we have another Kagan structure called Rally Coach. And this activity, one partner is kind of questioning the other partner, and they're going back and forth.
Experiment number 2, coins. Kind of the same thing. However, I have not given you coins just because that could get expensive if I have people taking my coins. But you have red and yellow. And probably what you want to do is, what is the theoretical probability of the coin landing on heads up? You may want to scratch that out and put yellow, okay, or red. If this is the experiment you decide to do, you may want to scratch that out and put yellow or red, whichever one you want to say. So you're going to have one person flipping it 30 times, and one person is tallying, and then finding the percent of the probability. Then you're comparing the 2. Which one had a greater? Which one had less? Are they close together?
Ms. Brangers was nominated for the Excel Award as a result of her excellent teaching over the last 5 years. Her students have always been in one of the highest in the district as far as map growth, through each of the 3 MAP assessments that we give every year, and that has been a continuous thing over her last 5 years.
And then the last experiment. We have not worked with cards, so I kind of want to give you a debrief of the cards. There are 52 cards in a deck, okay? There are 4 different type of suits, I guess you could say. We have hearts, clubs, spades, diamonds. So that means that there are 13 hearts in one deck, okay? So that kind of helps you out with finding the probability. There are 13 hearts, and there are 52 cards total. So you're going to write the theoretical probability, and then the next, you are going to draw out, you may want to shuffle them, and you're going to draw out 40 random cards, making sure you put the other card back, because that would change the probability. So you're going to put the cards back once you draw it. Someone is tallying if they get a heart, okay? There are 3 experiments. There are 3. You have to get through 1. You can pick 1. In this class, I would expect most to get through 2. Some people will get through 3. You decide. Some of them are harder than others. The number cube is probably the easiest one. So if you don't feel 100% confident on it, then go with the number cube. Experiment 3 may be the harder one. So if you want to start on there, if you feel confident, go with that. Okay, everybody understand what we're doing? Working with our partner. This is not one of those things. One person is doing everything. We have a counter and a tallier. Go.
I enjoy being in her classroom because math is like one of my favorite subjects, and she like makes it fun and makes me entertained.
Okay, good. Okay, now we have our decimal, so what percent is that? What do we do with our decimal? To make it a, how many places? Good. See, it says how many.
I enjoy all the positivity in there, and she encourages us a lot and tells us we can do it.
Okay, so what does this line mean?
Okay. So if we divide 1 by 6, what do we get? Our decimal, right? So let's see. Divide it. Okay. So we get this answer. So now we have our decimal. How do I change the decimal to a percent? No, we don't have to do it on here. What do we do with our decimal?
We move it over to 2.
Okay, so then what's that going to be?
16%.
Okay.
You remember that?
Students learn in many different ways. Like some students learn auditorial, some learn kinesthetically by moving, and so I try to hit all the different types of ways students learn. It may be today's lesson we're up moving around. It may be that I'm actually just direct instruction, or that they're working on something. A lot of times I also do collaborative, where they're working with a partner or working with a group, because sometimes students learn best from their peer.
So let's do this part first. So how many 5s are on a number cube? Okay, out of how many total outcomes? Okay, so then we have 1/6 here.
All right, and then we need to make this a percent. So not quite. No. So we have to divide. Max is right, we do need to divide, but go on and do that for me.
So 1 divided by 6? 0.16.
Now, is that our percent?
No, that's 1 out of 5.
That's right. Yeah, that's right. What do we do next?
It would be 16%.
Okay, because what do we do with that decimal? What are we actually doing? Right.
25 times we got 4.
Uh-huh.
Okay.
And then, Grace, I think you were right on this path where, how many 5s did you get? Okay, out of how many total? Right.
Ms. Brangers is very active in all the extracurricular activities that we do, through whether it be PBIS, culture and climate type aspects of the school. She has also helped train staff on Kagan instructional strategies. So she's very active in the things that we do outside the classroom.
All right, you can determine the difference between experimental and theoretical probability. That's the objective for today. Okay, that's what we were supposed to be learning. Can somebody tell me, let's look at our experiment real quick. Let's go to the coin, experiment number 2. So let's look at our coin. Okay, so everybody go to the coin. If you didn't get to the coin, it's okay, just listen. All right, my coin. What is the theoretical probability of it landing on yellow? What should happen? What should happen? Elizabeth?
1/2.
1/2. 50% of the time, it should land on yellow. 50% of the time. Raise your hand if when you flipped it, how many times did we flip it? 30? How many of you all got exactly 50%? Okay, a few of you. A few of you. How many got close to 50%? Okay, so theoretically, I should get it 50% of the time. Okay, we know that if I flip it twice, I should get it 1 out of the 2 times. That's what we're saying. But we just did an experiment to see if that was true. And theoretically, some of you it was true. Most of you, it was probably close. Okay, that's the difference. What actually happens in the experiment, the trials, versus what should happen. Okay, versus what should happen. That is what we were supposed to learn today, the learning objective.
She encourages us, like, if we get something right, she'll give us, like, a ticket. And, like, for so many tickets, you can get, like, a milkshake or something. And she just, like, fills us up with positivity. And, like, when we do tests, she'll tell us, like, we can do it. And
We have rally coach. Let's say the person with the longest hair is partner A. Longest hair is partner A. Sorry about that. All right, so partner A needs to write their name where it says rally. Partner B needs to write their name where it says coach.
She encourages us to be better by telling us to, like, if we're acting up, we need to, like, calm down, and it helps us later on in class, because sometimes we get, like, bored or there's something we don't want to do, but she encourages us to keep going, and it really helps us for later on in the day and later on when, even if we're not having a good day.
Partner A is going to read the question. So the first one is, what is the sample space for a number cube? Okay, they're going to read it. They're going to say what they think the answer is. If partner B agrees, they're going to say, good job, write it down. If partner B disagrees, they're going to coach, that's why it's called coach, not give the answer, coach them for the right answer. Okay, maybe if we're talking about number 1, a good example of coaching would be, okay, well, think about how many outcomes there are. What are the outcomes? Okay, instead of giving the answer, you are coaching them. All right, partner A will write the answer. If both of you are unsure of the answer, then at that point you do need to raise your hand and get some help from us. Okay? Then partner B reads the question, answers it, looks at partner A and says, okay, what do you think? Is that right? Do I need help? Partner B is going to say, good job. Or is going to say, but wait. Now remember, when you critique them, when you coach them, be as nice as possible. Don't say, no, that was a horrible answer. Okay? And then it's going to go back and forth, back and forth. Some of the answers are harder than others. Okay? And that question, where you can determine the difference, that is on here. Okay? That's probably the hardest question to put into words. Okay? All right, partner A, get started. You are saying it out loud, then writing it, making sure you are coaching, not giving answers. Go.
She encourages us to be better by, like, helping us do things and, like, pushing us to go forward and be good at math.
And if there's a word that you don't know, and it is a vocab word, what could we do?
Look at your vocab sheet.
Get your vocab sheet out.
She just pushes you so that like you can do your best, and like when it comes to math testing, she'll like set goals for us, and like she wants us to be confident about it.
What's the difference between the two?
That goes like what should happen. Like coin is got 2 chances.
Okay, and then what's experimental?
Experimental is like what did happen.
Okay, yeah, exactly. In my trial, good, my experiment.
The greatest joys are not only academic, however, I do love to see students grow, their math growth. I love seeing students come to me and say, oh, I grew so many points. But I also enjoy seeing students help other students. Like in the hallway when a student helps another student pick up their stuff, like that brings joy to me.
Experimental is what we do in the experiment, okay, versus theoretical, which is what should happen, okay? Okay? I mean, you gave the definition, but if you don't understand the definition, then it doesn't help you, okay?
I'll remember her because I love math and she's like one of my favorite teachers and she encourages us to do really good and it's fun.
And this one's kind of hard. Okay, explain why it's 36.
It's like the nose on the head. If you had 2, it was 4 possible outcomes, and then you could get more.
Good explanation. I like that. Good coaching, Sheridan. That's what you're supposed to do.
Because she's the only math teacher that's really ever made learning fun for me.
Good explanation. I like that. Good job, Brandon. Okay, so how many outcomes would there be on 2 coins? Good. And what would they be? Okay, awesome. Okay,
I will remember Miss Brangers as the teacher that always told me that I could do it and pushed me farther. And math is one of my favorite subjects, so she like tells me, like she'll show me something like more advanced.
But you don't have to write all of them. You just have to put how many. I mean, but if that's what you need to do, you can do it that way too. Okay, but we could also have 24. You're close. We could have 2, 1, 2, 2. If you need to write it out like that, then do that. Okay.
I think the number one thing that the teacher or the students will take away from being in Ms. Branger's class is the relationship that's been created, genuine concern for each and every child that she teaches.
So you have how many outcomes on 1? 6, okay? And then on the second one you have 6 outcomes, right? Okay. So then how many total outcomes all together? If you had a 6 by 6 array?
That's 36.
36, good. Yeah, good. Yeah, that's great.
I'm gonna remember Miss Brangers as one of the coolest teachers I've ever had, and I love her emojis. And she's really up to date, and she knows everything that goes on with us, so she knows how to connect to us. So she's by far been one of the best teachers I've ever had.
At this point, I think we are close to finishing. The learning objective, I can determine the difference between experimental and theoretical probability. Partner B, I want you to say one thing that you know about the difference between the two. Partner B is first. Reason I say that is because partner A had that question. So partner B says first what they know, and then partner A adds to this. Go.
Teachers are the most, like that career, every single other career relies on a teacher. Like we are teaching every skill that is required for everything. And I mean, we are shaping the future.